Hello there, my happy meteorology students. Dr. Shragi here, and I'm ready to talk to you about the different types of clouds that are out there. Now, we tend to kind of use the word species to describe the different kinds of clouds. We describe them as different species of clouds, cloud species, which is kind of a goofy term if you think about it. I mean, it isn't like there's different breeds of clouds or something like that, but it gives us a way to try to sort out clouds and describe them in different ways. This was a really hard thing, actually, in the history of science. Science had a hard time deciding how to describe clouds, and it wasn't until Luke Howard came up with this system, in the early 1800s, that we were able to start figuring out a meaningful way to describe clouds, in contrast to just describing what they looked like what was their shape, or something like that. Or we kind of got lost for a while trying to describe clouds by their exact shade of white, and so on. This wasn't very constructive, this wasn't very helpful. It wasn't until Luke Howard, famously known as the man who named the clouds, came up with this system that we use today. Now, when we're talking about these different kinds of clouds, the first thing to remember is that all clouds happen in that lowest layer of the atmosphere that we call the troposphere. We're talking about the lowest 10 or 11 kilometers or so. Nothing that you and I would think of as a cloud happens in the stratosphere, the mesosphere, or the thermosphere. There actually are some kinds of very thin clouds, like polar noctilucent clouds and things like that can happen in other layers of the atmosphere, but they have no meteorological importance. Everything that you and I think of as a cloud happens in the troposphere. The second thing to remember, of course, is that all clouds are caused by rising motions in the atmosphere. Remember, to get a cloud, our best way to have them happen is to have rising motion in the atmosphere, because that causes cooling, meaning our air particles' temperature is approaching the dew point. Approaching saturation is approaching a relative humidity of 100%, and therefore we get our air particles to expand and cool and eventually become saturated and we form clouds. We are eventually going to be having this air particle continue to rise past its lifted condensation level. Man, I am just swinging vocabulary words around here. But these are all words that you've been learning in this module. We're going to have lifted our air particle to its lifted condensation level, and from there on up, if we continue to lift the air particle, we are forming a cloud, and the air particle will continue to cool at the moist adiabatic lapse rate, as you learned a couple lectures ago. What was Luke Howard's insight as to how to name the clouds? He was the guy who realized that we should be describing them based on the processes by which they form. How would we articulate what they look like based on, not like, oh, that would shape like a bunny, but like the features of this cloud tell us something about how it was made. And broadly speaking, most of our clouds will neatly fit into the three categories that Luke Howard coined. They are the cumuliform clouds, the stratiform clouds, and the xeroform clouds. Now, these are going to be three words that you're not that comfortable with yet, but you soon will. But to be clear, this is kind of a rough way to break them out. We're going to have a few clouds that don't neatly fit into each of these categories and so on. But it gives us a vocabulary to start describing the clouds. And the first type of cloud that I want to talk about are the cumuliform clouds. Cumuliform, the word cumuliform is actually more modern, comes from cumulus. Cumulus, as in, is a Latin word that means something like heaped up or piled up. And cumuliform clouds look like little piles. They are clouds that are created by air parcels as they rise through layers of the atmosphere. In general, they're like an air parcel rising through air around it that is not rising. Most clouds that are cumuliform in nature have relatively large vertical developments. They are taller than you will expect when you see other clouds that we talk about, okay? Now, that doesn't necessarily mean that they're literally taller than they are wide. Like in this example that I have here in this picture here, clearly these clouds are not taller than they are wide, but they have more vertical development compared to their width than some clouds that we're going to see. Okay? And I think we would agree these clouds are a little bit flat anyway. I mean, you've seen clouds that are more puffy, and we'll see some examples here. Any kind of cloud that has that kind of vertical development is going to be a type of cumuliform cloud. Another characteristic that's often the case of cumuliform clouds is that they're often flattish on the bottom and puffyish on the top. The fact that they're flat on the bottom comes from the fact that we have lifted our air parcel from the surface, or from some level anyway, to the lifted condensation level. When the air parcel reaches that lifted condensation level, we begin converting water vapor into liquid water droplets, and we start making a cloud. The fact that they're puffy on the top has to do with they're still being formed by these rising turrets of motion. That's easiest to see in video. And so let's just like show you here some time-lapse video of some cumuliform clouds, and you can clearly see how each of these clouds is formed by these plumes of rising motion as an air parcel from the surface rises to its lifted condensation level, and then it penetrates farther up into the atmosphere, creating these towers of cumulus clouds. They are cumuliform clouds. Okay, you can go to YouTube and do a search and find lots of search on time-lapse cumulus, you'll find all kinds of interesting things. So like just to take a still photo here, here's a nice example of a cumuliform cloud, and once you know what to look for, it becomes clear, oh, you can almost see just by looking at it, how these plumes of rising motion as each of these air parcels is lifting from the surface up to its lifted condensation level, and then farther up into the atmosphere by the moist adiabatic lapse rate to form these cumuliform clouds. Here again, once we see, here's a perfectly lovely, this happens to be a cumulus congestus cloud. You don't need to know that term right now, but this is a cumuliform type of cloud. It looks like a heap, it looks like a pile, and it's formed by rising air parcel from the surface as it reaches its lifted condensation level. You get that nice flat bottom, and then the air parcel pushes farther upward, and as it does, it continues to make cloud material as it forms cloud droplets and so on, and you get that puffy top. Alright? Some cumuliform clouds are very tall. This is actually a thunderstorm here, or a cumulonimbus cloud. We'll learn that word more in the second part of this lecture. But I mean, again, you can see the flat bottom and the kind of puffy top to the whole thing. Alright, that's one type of cloud. Now, some types of cumuliform clouds are harder to see the flat bottom, puffy topness of it all. Like, for example, these are rows, or billows, to use the word we use in meteorology, of cumuliform clouds. These are billows of a type of, these happen to be cirrocumulus, but we'll get there in the second part of the lecture. This is, each of those lines that you see there is a whole line of cumulus clouds kind of side by side by side by side. Okay? Now, each of those little cumulus clouds that are there are a plume, an air parcel that is rising and reaches its lifted condensation level and has condensation. Now, these guys are fairly far away from the camera. It may not be so obvious that these are cumuliform clouds. And frankly, even in animation, this might not be entirely clear. On this particular animation, the low clouds kind of scooting past. That's something else. They're looking more at those clouds that are farther away from the camera here. But again, they're sliding past in the wind so fast compared to the rate at which they're growing. It can be very difficult to see that they're formed by plumes of rising motion as these air parcels rise. But they're still a type of cumuliform cloud. And once you start seeing the alternatives of cumuliform clouds, the differences start getting to be more clear. Let's compare those cumuliform clouds to stratiform clouds. Luke Howard picked this word stratus. We've kind of morphed it into stratiform to be an adjective to describe the clouds. Stratus is a Latin prefix that means something like occurring in layers, or very smooth, stratified, and so on. And generally speaking, stratiform clouds are going to happen when a whole layer of air is rising. Previously we were talking about air parcels, where some volume of air was pushing through a layer of air. So here's a volume of air, like an air parcel, pushing through a layer of air that may itself not be moving vertically. Now we're talking about, what if you had a whole layer of air that was rising? Well, just like any kind of situation where you're causing lifting, we're still going to have that air parcel that volume of air cooling and expanding and becoming closer to saturation and having its relative humidity increase. All the same good stuff works. But instead of it just being a single air parcel, whatever the hell an air parcel is, we've talked about the fact that that's still a hard question to answer. But instead of an air parcel, we're talking about a whole layer of air rising. And you're going to get these broad areas of fairly featureless clouds. They don't really have the kind of structures that like a cumulus cloud does. Nobody ever looked at a picture of stratus clouds and said, oh look, I see a bunny. Okay, no, you saw gray. Alright, it's just broadly covering the whole sky. It's overcast, to use the right vocabulary word here. The sky is covered with clouds. These air parcels are rising, well, this volume of air, this layer of air is rising when we make stratiform clouds. As it happens, the speed of the vertical motion does tend to be a lot less with stratiform clouds than it is with cumuliform clouds. Cumuliform clouds might have rising motion on the order of a few meters per second, Whereas a stratiform cloud, it might be a few fractions of a centimeter per second. The rising motions are just very gentle. You just kind of get a gray area of the sky. That's going to be your stratiform clouds. And, well, they're not all that photogenic. It's hard to see them there aren't a lot of great YouTube videos of, like, stratiform clouds rolling in or whatever, but you can picture this arrival of these layers of clouds. Here's a nice still picture of stratiform clouds, and you can see that it's kind of featureless or so on, but this is a whole area where the whole layer of the air is rising. And as that air is rising, it cools, it gets closer to saturation, it is developing, eventually reaching its lifted condensation level, and starting to condense water vapor into liquid water. It's a cloud, it's just that it's a stratiform cloud. Here's another picture of stratiform clouds. They're just very featureless. They kind of just have a broad, fuzzy, gray nature to them. There are going to be several different kinds of stratus clouds depending on the altitude at which they're occurring and whether or not they're producing precipitation, but they're just kind of overcast conditions. Sometimes it's really hard to make any sense of them. I mean, like on this picture here, the sky is just kind of white. Okay, it's just covered with a featureless cloud. You can kind of see the sun peeking through. The cloud is not physically very thick. Okay, this is just a thin layer of cloud. The sun can actually shine right through part of it. The sun doesn't generally shine through a cumulus cloud. So this is not a very thick layer of clouds, but it covers the whole sky. Alright, we've had cumuliform clouds and stratiform clouds. The third option was xeroform clouds. Xeroform clouds, the adjective xeroform comes from the Latin word cirrus. Unfortunately, at this exact moment, it escapes me what the word cirrus means. But they are the highest of the clouds. They actually typically occur very high in the troposphere, in fact, maybe up near the tropopause. And generally speaking, these clouds are going to be made completely of ice. Okay, we are high enough. Remember the temperature profile in the troposphere? Temperatures decreased with respect to height in the environment. If you measure the temperature here, and then you go to a new height, and you measure the temperature there, it can be much colder in the troposphere. Well, by the time you get up to near the tropopause, temperatures are so low, there's no supercooled water anymore. It's all ice. Cirrus-form clouds often have that kind of fibrous appearance that you kind of see in the background of this image here. They kind of look like hair or smoke or something like that. In fact, let me show you a YouTube video first. It's hard to find good YouTube videos that show like animations of cirriform clouds, in part because they don't photograph very well. It's hard to keep the camera focused on them. But they are very high, and they're very icy, and they're very thin. The distance between the bottom and the top of the cloud is not very high. They're still formed by rising motion in the atmosphere, but they are a very thin layer of clouds. Again, just to show some examples here, these are a very clear example of some cirriform clouds, where they're just sort of thin, wispy, they kind of look a little bit like hair or cotton candy or something like that. This is going to be a cirriform type of cloud. They often have kind of more of a feather kind of appearance to them. There's some other cumulus clouds or something lower in the picture, but the bulk of the picture here is taken up by some very wispy cirriform cloud cover right there. Now, before we start picking each of these categories apart, stratiform, cumuliform, all that kind of stuff, let's answer two quick questions. Hey, I got a picture right here. That cloud shown in that picture there is an example of a blank cloud. Cumuliform, stratiform, or cirriform. That shouldn't be too difficult. Make a choice from those three options and get a little feedback before you move on to question 2.